Hey, hi everyone. So in the last video we discussed about some sort of system design and all that, but in today's lecture and the following lecture we are deep diving in the core concept of system design. So in this video we are discussing about single server system and distributed server system and what is this and why it is. So first understand what is single server system. The single server system is very important. Not very important actually, it's very easy. So suppose this is your server. Let me choose the pen. This is your server. Okay. Now this is your only one server you have. Only one server. Suppose you create an React application or Node.js application and you have one VM and you install or run your backend on that VM. Okay. That's it. So all the requests that is coming to your from your API are directly hitting from to this server. Okay, but what if this VM got down? What if there is some network latency happened in the server that is in the place that is this VM is hosted? There is something happened and this is got corrupted, deleted, or anything happened with that. So what will happen? What will happen? All the request gives you 404 or 503. No, not 503, it's give you 404 because the request eventually did not find, they are not able to find anything. Okay, so why it is happening? Because the uh, the problem is here you have only one server. You have only one server and all the dependencies you have only on this particular server. So that's why this is the single server system is very less fault tolerant. Okay, now to outcome this, to like remove this limitation, we created a new system which is a distributed server system, in which if you see, these are the servers that is running on a different location, different places, and from different areas. Like suppose this is from New Zealand, this is from Delhi, this is from Dubai, and this is from US. So these are working from different locations. Suppose New Zealand servers got corrupted, the client can ask data from Dubai one. If Dubai one got corrupted, they can ask from the Delhi one. So these ways we can ask the data from different server located on a different location, so they are fault tolerant. So suppose once this server got crashed and everything got crashed, everything got deleted. So we can create a replica from other place, from other server, and making that server up. Okay, so now if you see, we are make this system fault tolerant, means from one place we are getting the data, from another place getting the same data, third fourth place getting the same data. But if you see, there is a one problem, there is a one big problem. They all are from different time zone. First is different time zone. Okay, so let's understand 3 point that is very important to understand this thing. First is network latency. In the case of distributed system, the problem is first is network latency. Suppose in the case of here, you update the server to add 5 plus 1 equal to 6. So you update the server to 6. This server have to update all the server to 6. So so if the client asks from data from this server, so it doesn't serve to the customer to the stale data. Means stale means old data. Stale means old, means cached data. So it doesn't serve the customer or client to the old data. So it have to be network in the context of network latency, like it's too smooth. Like if each read operation he get it, if it automatically get the right operation, so it will work like smooth. Okay, next is clock drift. Clock drift is like suppose your one server is located in Dubai, your one location in Noida, is in London, it's in New York. So if you their time zone, their exact time zone is different, so the problem will arise. Suppose And okay, I will give an example of clock drift after that. And the third part is unreliable synchronization. It means, suppose the same example as given in the case of network latency I gave to you, but it is a context of network, that is you have a proper network connection and communication and all that. You have a good latency. If it's not that, it will give you unsynchronization. Same in the case of here. You have to make that your each server must sync to each other properly. So the data on A must be same as data on B. Okay. Now I will explain you the particular context of clock drift also. So suppose we have a user A. We have a user A. Okay. We have a user A, and user A send a request at 12 a.m. at their local time. Okay, and this person user B send the request later but at 11:59 a.m. at the local time, means this is from Dubai and this is from India. Okay, now what will happen, the no the time what timestamp will change on a different server. So suppose you have a chat application running on, so user A chat come first, and so user B chat come first, and user A chat come later. So it create a clock drift. Means depend upon the locality, depend upon the place, it change the particular timestamp. So it's very important to understand how we can avoid these kind of situation in future, like design the system. So for avoiding these clock drift and synchronization and all that, we have few methods, and you can say mental model we created to avoid all this. So these are called logical clock and event ordering. We learn about all these in the next lectures. Logical clocks, I will explain you. Logical clock is like, it's not the actual clock, it's like a logical clock. Like, we decide on the basis of when the event occurs. Understand my point? When the event occurs, increment we increment or decrement the particular thing on the different node. So it's not a actual clock, it's just a logical clock. Okay, and in the case of event ordering, what we have in the case of event ordering, like when the order of event occurs, like A happened before B or B happened before A. Event is like processes, like A send message to B first or B send message to A first, in that context. Okay, so in the next lectures we are discussing about the further algorithms that used to avoid all these of situations while designing the system. Okay, and thanks for watching and stay tuned for the next video. Bye bye.